Hey everyone, and welcome. Today, we're going to do something really cool. We're going to build a production-ready microservices system, right from scratch, and we'll be using a super powerful combination, RabbitMQ and mass transit. Welcome to such our next-gen tech. I'm really excited to walk you through this. Because let's be real, if you've ever found yourself wondering, how do I build microservices that don't just fall over in the real world, then you are absolutely in the right place. Stick with me, and by the end of this, you're going to have a solid, practical blueprint for building systems that are actually tough and reliable. All right, so we're going to break this down into 3 simple steps. First up, we'll get the basic connection working. Then, we'll focus on building for failure, because let's face it, things break. And finally, we'll layer on some pro-level patterns to make sure everything is solid and you can actually see what's going on. Okay, let's dive right into step 1, the core connection. So, how in the world do you get 2 totally separate services to talk to each other when they're not even directly connected? Well, the magic word here is asynchronous communication. And the secret sauce for that? It's something called a message broker. Think RabbitMQ. The best way to picture it is like a central post office for your services. One service can just drop off a message, a letter if you will, without even caring if the other service is online to receive it. The post office, our broker, just holds onto that message safely until it can be delivered. This simple idea is what makes our services decoupled and honestly super resilient. Now, what's really cool is how mass transit makes this whole thing feel like a simple 3-step dance. First, your services need to agree on what the message looks like, that's the shared contract. Then one service, the publisher, sends the message out. And finally, another service, the consumer, picks it up and does something with it. It's really that simple. Let's look at some code. Check out the publisher here. This is our order service. So after it saves a new order to the database, boom, it fires off this one line of code to publish an order-created event. It's basically just shouting into the system, hey, an order was created. It has no idea who's listening, and frankly, it doesn't need to care. And then, on the flip side, you've got your consumer. Let's imagine it's a notification service. It sets up what we call a receive endpoint. You can think of this as its own personal mailbox, and it gives it a name like Order Created Queue. It's basically telling the broker, hey, if you get any of those order created messages, just stick them in this mailbox for me. So right about now, you might be thinking, okay, but why not just make a direct API call? Wouldn't that be easier? Great question, and the answer is all about building for the real world. You get 3 huge wins here. First, temporal decoupling. Fancy term, but it just means your services don't have to be online at the same time. Second, scalability. Need to handle more orders? Just spin up more consumers. Easy. And maybe the most important one, no data loss. If your consumer crashes, the message is safe and sound, waiting in the broker. All right, that brings us perfectly to step 2, building for failure. Because we just touched on it, right? What happens when things go wrong? And trust me, in a distributed system, things will go wrong. It's not a question of if, but when. Networks tick up, services crash, you have to plan for it. So here's the big question. What happens when your consumer fails to process a message? Imagine our notification service gets an order message, but oops, the third-party email service it relies on is down for a minute. What do? You can't just throw that message away. You need a safety net. And this is where mass transit really shines. It gives us 2 amazing tools for exactly this scenario. The first is what I call the try again phase, automatic retries. If a message fails, mass transit just says, no big deal, I'll wait a few seconds and try again. But if it keeps failing, it moves to the hospital phase. The message gets sent to a special dead letter queue, a DLQ, where an engineer can look at it later, all without holding up the line for all the other perfectly fine messages. And you won't believe how simple this is to set up. Seriously, look at this. This single line of code tells mass transit, hey, if this fails, just wait 5 seconds and try again. Give it about 3 shots before you give up. That's it. It's like an instant shot of resilience for your service. Okay, but what if that email API isn't just having a hiccup? What if it's completely down? Hammering it with retries over and over is just, well, it's pointless. It wastes resources. That's where the circuit breaker pattern comes in. It's so clever. When it sees a ton of failures in a row, it just trips the circuit, just like in your house. It stops sending requests for a little while. This gives that broken downstream system a chance to breathe and recover, and it stops a small problem from causing a massive cascade failure in your own system. Hey, quick pause. If you're getting value out of this and finding it helpful, do me a favor and hit that subscribe button. We're always doing deep dives like this one, all designed to help you build better, more essential tech. All right, let's get into step 3, production-grade patterns. So far, our services can talk and they don't fall over at the first sign of trouble. That's great. But now we're going to add the patterns that really separate the weekend projects from the serious production-grade systems that you can actually trust with your business. And this brings us to one of the trickiest problems in all of distributed systems. How do you guarantee a message is processed exactly once? See, because of network weirdness, it's possible for a message to get delivered more than once. And if that message is something like, charge this credit card $50, well, you can see why processing it twice would be really, really bad. So, how do we solve this? The solution comes down to a few incredibly powerful patterns. We're going to focus on two main heroes here, the outbox pattern and the inbox pattern. They work together like a perfect lock and key to give you rock-solid data consistency. There's also the saga pattern, which is awesome for handling those really long, complicated workflows that span multiple services. So here's the deal. The outbox pattern is all about reliable sending. It makes a promise. If your business data gets saved to the database, that outgoing message will eventually be sent, no exceptions. It does this by cleverly saving the message and the data in the very same database transaction. Then you have the inbox pattern. This is all about what we call idiopotent processing, a fancy way of saying exactly once. The consumer just keeps a little list of all the message IDs it's already processed. If a duplicate message shows up, it just looks at its list, says, hey, I've seen you before, and tosses it. Simple, but so effective. Okay, this is amazing. We now have data integrity, our system is reliable, but there's a problem. We're basically flying blind. If a user complains that their request was super slow, how do we figure out where the bottleneck is? We have no idea. We need to see what's happening inside. The answer to that is something called distributed tracing. And honestly, it's the closest thing we have to X-ray vision in software. It lets you follow a single request on its entire journey across all your different microservices. You can see it go from service A to the message broker to service B and see exactly how much time it spent at each stop. It's a total game changer for finding bottlenecks. And the standard way to get this superpower these days is with a stack like this. You put a sensor in your code, that's the OpenTelemetry SDK. That sensor collects all the data. Then a messenger, the OTLP exporter, ships that data off to a UI like Jaeger. And Jaeger is where you get those beautiful visualizations that show you the whole trace from start to finish. So let's just pause and take a look at what we've actually built here. We started with just getting services to talk. And now, by following these 3 steps, we have a system that is, well, it's decoupled, it's asynchronous, it's resilient, it has data integrity, and we can actually see what's going on inside it. This isn't just a bunch of services anymore. This is a real professional production-grade architecture. So your system is built, it's reliable, it can handle errors, but is it truly ready for the absolute chaos of production? The real world is always messier than you think. So the question I want to leave you with is this. Now that you have this blueprint, what's next? How are you going to push this system to its limits and make it even stronger? Thank you so much for joining me for this Sukar Next Gen Tech Explainer. I really hope this has given you a clear, actionable path forward for building your own awesome, robust microservices. Until next time, keep building.